Hello, chat people. We are Dale here. So I will be teaching you chemistry in the atmosphere. So this is part of your subject, the chemistry for engineers. So first, let me introduce myself. So I am uh, okay. So this is the uh, subject that we will be learning today, and also the topic. So first, I am Findale B. Lopez. So I'm a former deputy XU, Comelec chairman, and then also the XU Elecom commissioner. So, and then former Elecom chief legal counsel. So, sa election dito guys, ano po ang background with I love holding elections. And also, I was the chief legal counsel for me sa XUCSG Telecom itong time. And then, there's also a legal student council of the integrated bar of XUCSG. So, maghapon, attorney hapon ako ang work, ako ang time. And then, I graduated this year lang, 2020, at XU. Okay? And then, I am currently the area representative for North Mindanao, the Philippine Institute for Chemical Engineers, Young Engineers section. So, what we will learn today is in the chemistry and atmosphere. So, muna siya ang outline sa ato ang lecture karon nga hapon. So, first we will talk about the Earth's atmosphere, what is in it, and then what are the processes that are in it, and then phenomena of the outer layers of the atmosphere, and then we will also learn about the deposition of ozone in the stratosphere, and then volcanoes, the greenhouse effect, and acid rain, and then photochemical smog. So actually, there is one topic that I did not include here, but that's the last topic in your chapter, and it's called the indoor pollution. So I trust if you will read it on your own, and then it's really easy to understand. And I will not include it here because this video will take too long. So wala siya. So first, we will talk about the Earth's atmosphere. So what is in the Earth's atmosphere, guys? Oh, di ba? So first, natay nitrogen. So natay, so that we have nitrogen cycle. So there is atmospheric nitrogen. So there is atmospheric nitrogen. It exists naturally there, and then it will be that atmospheric nitrogen will go through the plants through biological fixation. This is called the nitrogen fixation, and usually it is done by bacteria. And ginawa bacteria, it's found in leguminous plants, for example, peanut, o mani, mga plant. So it will fix nitrogen, and then it actually makes its own fertilizer. So tambok ay siya, and then kung matay na ni ang imong plant or ang talang imong, and there also kung kanon siya sa imong baka, eaten by an animal, and then that animal dies. So the nitrogen is part of its protein also, and then if those plants or animals die, so will break down to ammonium, to nitrite, to nitrate, and then it will be broken down also by bacteria. And then we have the process of nitrification. Diba? Nalam kay nitrogen man ni hapon naman si nitrogen, and then this will be transformed to nitrous oxide, and then denitrification from here siyang into so ang kuan ani ang form of nitrogen as it exists in the atmosphere is diatomic, diba? So N2. But our focus usually in chemical engineering is in the atmospheric fixation of nitrogen and the industrial fixation. Commonly, as chemical engineers, our interest is in the industrial fixation of nitrogen. So, ito magdugay. Let's continue. So, there are two. So, as I mentioned earlier, the atmospheric nitrogen fixation and the industrial nitrogen fixation. So, what is the atmospheric nitrogen fixation? It happens when there is lightning. So, kung gabing kilat sa inyong lugar, there is thunderstorm in your area. So, you would expect that there is nitrogen fixation happening. So, what are the processes? So, here is the process, diba? Nitrogen exists in the atmosphere as the atomic molecule. So N2, and then it reacts with the oxygen in the atmosphere, also exists in the atomic molecule as a dynamic molecule, and then they will be combined together. They will react using the electrical energy from the lightning, and then they will form the nitrogen oxide. Next, after that, the nitrogen oxide now will react with oxygen to form the nitrogen dioxide, as they're all in gaseous forms. And then finally, this nitrogen dioxide in the atmosphere combines with water to produce the nitrous oxide or nitrous acid. Nitrous acid and the nitric acid. And our chemical of interest is this nitric acid, because it is the precursor for our fertilizer. But we can't always rely in the process of nature, because admit it, we can't have a perpetual thunderstorms to make these kinds of um, chemicals. So naatay industrial nitrogen fixation, which is the focus of chemical engineering. So what are those? So we have here, siya in the industry, how they make ammonia from nitrogen and hydrogen. So what they did to produce the fertilizer na ato ang kinahanglan karon is that they react nitrogen in the atmosphere with 3 moles of hydrogen, and then using a catalyst. Usually this is a iron catalyst, and then this process happens in high temperature and high pressure. So this is called the ano guys, Haber-Bosch process. So this is called the Haber-Bosch process, and it was discovered in the 20th century, 1900s. And then that ammonia, this is ammonia nga ato nga produce karon, it will be reacted with oxygen, so it will be oxidized. So oxidized siya kay butang siya of oxygen, and then this process is called Ostwald process. And you must remember this, because these are two very important chemical engineering feats in the modern times. Okay, so I'm giving you trivia. So, and then the nitric acid that is produced in this reaction, it will be then formed. It will be combined with the ammonia is formed in the previous reaction to form ammonium nitrate. So ammonium nitrate, muna ni siya imuhang fertilizer. So muna na siya imuhang fertilizer. So if you remember the explosion in Beirut, Lebanon recently, so muna siya nga chemical, ammonium nitrate. And then why are we focusing on nitrogen? Because nitrogen is the here is the ink. So this I think so. Actually, nitrogen is the most abundant gas in the atmosphere. So it is 78% by volume, and O2 is around 21%, and argon 9.94 and 0.33. So other gases, these are noble gases, so they exist in trace amounts. So kung gusto makuan sa inyo ha, nga magtun-an ninyo karon is that in chemical engineering calculations, this we designate the percent abundance of uh, nitrogen in the atmosphere as 79% and 21%. So it may not be uh, it may not be important to you now, but in your next year, in your calculations, so this is really a handy formula or a handy information for you to solve uh, problems in the future. Okay, so let's move on. So we also have oxygen cycle aside from nitrogen cycle, and our area of interest here because as we are in the atmosphere, so uh, we have different forms of oxygen. So we have the elemental oxygen, which is the NO, elemental oxygen, and then we have the oxygen that exists in the atmosphere as diatomic molecule, and we also have the most important uh, form of oxygen in the atmosphere, which is ozone, O3. Okay, so let's move on. And then I a little bit of information. This is also in your book, but I would like to share it to you. So these are the four layers of the atmosphere. Actually, there is a fifth layer of the atmosphere. Do you know that is? So I remember our quiz in environmental engineering. We were asked about the one in five layers of the atmosphere. So one student nakalimot siya sa fifth. Nakalimot siya sa fifth. Nakalimot siya sa fifth layer of the atmosphere. So ang isa yung gitubag, ana siya, troposphere, stratosphere, mesosphere, then thermosphere. Lima man jud to bay. Ayun yung gisulat kay kuan, Britney Spears. Okay, nalimot naman yung Johnson. Sige lang. Hindi na. Yan lang. Bubalatan. Sige. What are the important layers of, what are the importance of these layers were in the atmosphere? So, troposphere is muna siya karon. For example, ako diri karon, this is a layer of the atmosphere. Karon ako sa akong kwarto, and this is also a layer of the troposphere. So it extends from the sea level 10 up to 10 kilometers in the sa ibabaw, 10 kilometers because this is in kilometers. So kiniday siya, this layer of the atmosphere is where all weather conditions nakahitabo. So kung ay bagyo, kung naamagali ulan, unsa pa na diha ng mga weather conditions, it all happens in the troposphere. Tanan. And then next is the stratosphere. So an amazing information about the stratosphere is that naadri ato ang ozone layer. So here is where our ozone layer, and also this is the altitude that the commercial airplanes fly. So this is way up, from the sea level. And also next of the stratosphere, we have the mesosphere. So actually, the feature anemia in the mesosphere is that it is the coldest part of the atmosphere. So it's the mesosphere. So kita ninyo, a negative 80 from 0 to negative 80 degrees ang yung range. So bugnaw kaayo. This is the coldest part. And then when we go way up, we have the thermosphere. So thermosphere na diri ang ato ang mga gases nga they exist in their elemental form. So kining ato ang nitrogen. So here is there is ato ang thermosphere. This is where the aurora borealis happens. So I will explain to you what this is. What is this beautiful phenomenon? And then way up, the space, this dire magkuan ang space shuttle, and then actually the fifth layer of the atmosphere is the exosphere. So wala nila gi-appeal there because it is not uh, uh, was not included in the book, but there is a fifth layer of the atmosphere which is called the exosphere. All right, so let's move on. So diri day sa kuan ato ang atmosphere. So I will explain the what happens especially in the thermosphere. So in the thermosphere naatay ionizing radiation or ato ang UV na lights, and then UV rays. So they will react with the gases and the that part of the atmosphere which is the uh, thermosphere, diba? So it will energize, will react with the oxygen here. So and then it will be energized. So meaning aning asterisk diri, meaning is it will be energized. And then as it goes back to the ground state niya, because kung for example excited kay ka and then mawala magiging energy, diba? If your energy will be lost, if you will return to the ground state. So accompanying that return to the ground state is the emission of radiant energy. So nakita nimo nga mag-give off siya of light if you have um, if you have performed that experiment in your high school before. So we have this other mga solutions nga kung imuhang sunugon, maglahi-lahi ang colors sa flames. So, na ay red, na ay violet, na ay yellow, na ay green. So, ana. So, muna siyang kahitabuan ni diri. So, and also, diri sa ato ang oxygen, so energize siya, and then will emit an electron, then kung nitrogen, ma-energize food siya, and then pag return niya sa ground state, will produce proton and electron. So what happens na yun kung what happens if the oxygen and nitrogen in the atmosphere returns to their ground state after being energized? Una siya nga na rin kay aurora borealis, diba? So kada kayo ni siya nga phenomenon, and it will be seen in the northern hemisphere and the southern hemisphere, and unfortunately di natin nakita kay naam ko equator. So kana siya guys, ano na siya may tabo. So unsa ni siya nga mga colors di ay, di ba? So di ba as I said, excited state ni siya, energized state ni siya ni electron ni oxygen. After pabalik niya sa ground state, it will release the radiant energy, and then makita din nimo na kanang green diha and then the red parts are diha are the oxygen, and then kanang green blue diha o violet, those are from the nitrogen. So actually naapoy uban, naapoy other chemicals na give off siya og ana gihapon. So this is the glowing tail section of the space shuttle. So unsa ni siya nga mga elements? So unsa ni siya nga compound? So we have the nitrogen dioxide. So if the nitrogen dioxide will be energized siya because this is in the burning of the fuel inside the space shuttle. So it will be energized. Pag energized niya, will give off a radiant energy. So photon. So, it will give off radiant energy, and then as it gives off the radiant energy, gawas ang orange na light. So ani, this is the nitrogen. So gamay nga trivia sa inyo ha. But those kini siya, this is called the aurora. So but I don't know asa ni siya lapit, sa northern hemisphere ba ni siya or sa southern hemisphere. So muna ka og aurora, duha man nakabuok na ay borealis and australis. List. So asa man diri ang northern hemisphere og sa southern hemisphere. So ang borealis is sa north, and south ang australis. Okay? So that's one sa inyo ha. Previous sa inyo ha. Okay? So let's move on. So ginaunsa de how is ozone depleted in the atmosphere? So first we'll talk first about production. So we're gonna produce day ang oxygen, guys, by, di ba, ganyan kita mag-inila itong oxygen cycle. So katong oxygen cycle ganina, kung maigo siya sa ionizing radiation or the UV rays ikan sa sun. So mag-break down siya, it will be broken down, it will decompose to its elemental form. And then as it forms the elemental form, this oxygen will react with the additional or the remaining oxygen in the atmosphere, and then kining O plus O2 mahimo din siya O3. And this requires energy to because this is non-spontaneous, so it requires energy. So as it as energy, ang mag-carry sa iyaha na compound, for example, katura pong ihang kauban, which is ang nitrogen. M is any gas here. So you can name this as nitrogen, but for purposes of generalization, nitrogen atong M atong ibutang. And how is UV depleted? So UV, so the same rig hapon nga UV nga the form sa iyaha, mo rig hapon ang breakdown sa iyaha. Mo rig hapon the same UV that breaks down. So magbalik siya sa O2, and then magbalik na siya balik O2, and then this O2 will be broken down by the UV, and then it forms O3, and then O3, you know, it's endless. So how unsay tawag ana? So it is actually called a dynamic equilibrium. So if the production, if the naay kuha nato na reaction nato, butang nato nga ang forward ang production the backward is the depletion, diba? Depletion. And production ay produce, and then depletion. Actually, it's in dynamic equilibrium. So the rate at which it is produced, mupod siya ang rate as it is depleted. So actually, ang natingin ka nga, unsa lugar ang concentration sa ozone in the atmosphere, kuya? It's actually constant, diba? Because it is formed as it is depleted. So cycle na dito, guys. It is formed as it is depleted at the same rate. So muna siya. And if you will learn about it in your kinetics, but I'm just giving you the background here. And so ingani, hinali ko GIF no para makuha ninyo, ma-visualize ninyo how ozone is formed, and also how ozone is depleted. Kining gamay nga this represents the UV rays that ionizes or breaks down the ozone to elemental oxygen and diatomic oxygen. Okay? So as I've said, kining M is the carriers atong O2, and then wala siya. Helps in the reaction. Okay? So let's move on. Wala siya karon. Ato ito karon is how do we contribute to the destruction of ozone. So if makadumdum mo, if you remember or if you know this, compounds. These compounds are actually called the CFCs, or the chlorofluorocarbon. And naani siya sa atong mga ref, sa ato ang air conditioner, o atong mga aircon, and daghan pa kanang mga processes that needs cooling. So na siya. And if it escapes in the atmosphere, so tangta lang naani siya sa atmosphere, kining CFCl3, one of the chlorine anak niya will be broken down, or cleave siya ba? Cleave, maputol. I actually have a para ma-visualize ninyo unsa ang gakahitabo in the atmosphere. So, example, mo siya ang CFC, chlorofluorocarbon, na kuan to the chlorine, ba? So, as the quantum derivation cleaves that the chlorine gikan sa O3, makuha niya oxygen from the O3, right? So makuha niya, and then this ClO will react with the elemental oxygen in the atmosphere, forming oxygen. So the net na reaction karon, if remember ninyo sa inyong thermochemistry nga, kung i-add ni siya, di ba, mag-cancel sad na siya, and mag-cancel ni siya because they are in the opposite direction. So unsa opposite sides. So unsa yung mabilin karon nga net na reaction? So di ba, O3 plus O, and then 2 moles of oxygen. So as you can see, the chlorine catalyzes the reaction, and the net reaction is the destruction of ozone. Wala gyoy kuan, the ozone will not be formed again because the chlorine is a radical, so it exists in the atmosphere as Cl minus, as chloride. Kini siya, chloride din siya. And it is really reactive, and when it is broken from the molecule, it finds a molecule to react with, and then naamay ozone conveniently sa atmosphere. Mula siya nga maguba gid ato ang atmosphere. Okay? So diri this is in the America. So a big part of their usage of CFC is in the auto air conditioning, sakyanan, and then commercial refrigeration, ang ref, also food, so the cleaning and home insulation, and realize that this the parts in medyo orange or peach is not feasible na ang recycling, but we can recycle the CFCs in the purple, parts in the purple. Okay, so let's move on. Muna ni siya ang ozone depletion in the atmosphere. So through the years, so the ozone concentration of the atmosphere is measured to Dobson units. So Dobson units kini. Dobson units. If makita ninyo sa inyong diri, ang kanading purple di ay purple. Ang pasabot ana is the concentration of ozone in that area is low. So muna siya naka-inring ozone hole because the concentration of ozone in that area is relatively smaller than the surrounding area. And also the red muna siya ang pinaka high concentration. So this is taken through the years. So if you notice, kadako gyud ang hole. Because at this time also, muna siya ang discovery and the manufacturing of the CFCs, and wala sila kabalo na it has a negative effect in the atmosphere. It's depleting our ozone. So muna na kadako ang ozone hole through the years. But I'm happy to tell you that this ozone hole is healing. Okay, so in the 1990s, we have the treaty sa mga nations called the Montreal Protocol. Montreal Protocol na gaban og mga ozone depleting substances or ODS for short. Ozone depleting substances. So ginaban natin niya itong mga CFCs nga atong gipang discuss kanina. So actually kini siya, it was kini na-amend din ni siya to Kigali Amendment recently lang atong 2016 I think. Kigali Amendment. Kigali Amendment. Not sure if mo ba siya experience amendment. Amendment. Basta Kigali Amendment back in 2016. So that renewed the Montreal Protocol because the Montreal Protocol is long taas kaya siya na implementation. And then as you see, the hinahinay na og kahil ang ato ang ozone hole in Antarctica. So, di ba, ganina purple mo to karon tanawin niyo. But 2017, the blue na siya. Okay? So, next. So, we'll talk about volcanoes next. So, may significance sa volcano. What is the significance of volcano in the atmosphere? So, sa sa pagbuto when the volcano erupts, it releases the hydrogen sulfide in the atmosphere, so H2S na siya, and then it reacts with the oxygen in the atmosphere, so producing sulfur dioxide and water vapor. Okay, so what is the effect of this in the atmosphere? So it will react with the hydroxide radical, and then it forms the H2SO3. By the way, it's already an acid and also this H2SO3 reacts with the oxygen in the atmosphere, and then HO2 or hydroperoxyl. This is called hydroperoxyl, and actually this is my one as I have studied. Karon ko kita hari HO2, dili ka H2O lang. And then it forms the sulfur trioxide, and actually muna ato ang gabantayan kining SO3 because when it reacts with water, it forms the sulfuric acid. So sulfuric acid, kung mag-ulan, acid rain labas. Diba? So, but ang naani siya because this is gas kung siya, diba? Gas. So it exists as gas in the atmosphere. So it is an aerosol. So it has a cooling effect on the atmosphere. So if you remember when Mount Pinatubo erupted in 1991, the global temperature at that time dropped by 1 degree Celsius. So doon tayo siya doon. So nga na ito, because it blocks the through the ash, it blocks siya sa sun rays na from reaching the earth. So muna, cooling the earth's surface by 1 degree Celsius. Okay? So move on. So muna siya ang significance of volcanoes. Okay? Next, greenhouse effect. So greenhouse effect, actually my favorite na i-discuss sa inyo. Greenhouse effect, why is it called greenhouse effect? So greenhouse effect, ato sang tanawon sa ato ang greenhouse, literally greenhouse dito guys. Greenhouse because as the sun's energy, so sunlight goes through this mga plants, diba? So kani sila ang mga processes. So it will transpire from transpiration, so it will release from the reactions here, magkuhanin siya o water vapor, and then also it produces carbon dioxide but in little amounts. Pero the radiant energy na musulod rin sa imong greenhouse cannot radiate back to the atmosphere because it, these are blocked by the transparent roof or transparent wall. So muna siyang kahitabo sa greenhouse. It is prevented by escaping. So in the global scale, how is greenhouse effect observed? So diha sa ako ang atmosphere, we have water vapor and then carbon dioxide. Actually, napagani uban ana napagani methane, which is CH4. So CH4 is also a greenhouse gas. So if it is radiated by the sun, so it excites, di ba? So muna itong kanina, it is excited. So raise iyang energy. And then as it absorbs the energy, it heats up, and then it prevents or it acts as a greenhouse. It acts as a greenhouse na ma-prevent niya the solar radiation from the sun to radiate back to the atmosphere. So muna siya, and actually this is a good nakuan sa una. This is a good phenomenon sa una because it keeps the Earth's temperature, Earth's surface warm and possible for uh, uh, biological processes. But ang nakahitabo man gud, magkadaghan na ni siya, uh, if it will accumulate and then the amounts is not regulated, so wala global warming ang labas because this phenomenon raises the Earth's temperature. So actually naganit tayo ginagawa na karon na the Paris Agreement. So Paris Agreement. This Paris Agreement, mugyapon ihang goal, but ang ihang goal is to keep the global temperature from rising 2 degrees Celsius. So, kinahanglan dili na mo raise ang global temperature by 2 degrees Celsius. That's actually if you can read more on that. And next, mutanaw sa kuha. Kuya, kung ang nitrogen and oxygen, sila di ba sila man ang major nga component sa gases in the atmosphere, why don't they contribute to the greenhouse effect? Good question. Tubag din ko. Inyo din kung sendan ani. Kuya, o di ba yung gamay na kaya ang CO2, ana ninyo kuan. Sendan ko, dako kayo ang percentage sa nitrogen and oxygen. Tubag din ko guys. Tubag sa inyo guys. Is N2 and O2 cannot absorb IR radiation. So it's actually a bit advanced for you, but muna ako ang explanation sa inyong book. So kini siya, you can if ikapoy na mo, pwede niyo ni exercise, so it can stretch, bend, X, Y vibration. So muna siya, this is a water molecule. So let me write that for you. This is the water molecule. And kining nasa tunga mo na siya ang oxygen, and these are the two hydrogens na nakakabit sa iya. So, and also, yun ba yung ko, diba? Water vapor and carbon dioxide. This is CO2. CO2. This is CO2. So, this is CO2. So, kita ninyo, ga-vibrate siya. If it is hit by the UV or the actually IR is part of the electromagnetic spectrum. So it will be excited, diba? So it will be excited, and the criteria for this excitement is the IMFA or the intermolecular forces of attraction. So you've learned that back in your general inorganic chemistry back in senior high, I think. So N2, if you can remember, N2 and O2 are non-polar molecules. Diba? Non-polar. So non-polar molecules only have the van der Waals na intermolecular forces of attraction. So we have three intermolecular forces of attraction, right? So one is the van der Waals, which exists uh, in all particles, or in all non-metallic na mga compounds or covalent compounds. And then the second one is the dipole-dipole moment. So na siya, dipole-dipole moment, dipole-dipole moment um, exists in polar molecules, and then the hydrogen bonding din ang last, which is also the strongest kind of intermolecular forces of attraction, di ba? So van der Waals, dipole-dipole moment, then hydrogen bonding. So sa water na po, sa water, we have the hydrogen bonding because natay H nakakabit kabit sa O, right? So muna siya nga absorb gina siya IR or infrared na IR, infrared radiation. Then it does this vibrations na pili ka sayo. And then CO2 also is vibrated. So naa siya dipole-dipole moment ihapon. Na siya dipole-dipole moment. So it is it has two modes of vibration guys. So muna siya ang reason why these two are mag-absorb din sila o mag-contribute sila sa greenhouse effect because of this explanation. Okay? So next. Ito naman guys. So carbon cycle na rin ang sunod. So carbon cycle is the carbon cycle. So actually, so di ba, we breathe in oxygen and then we breathe out carbon dioxide. So it is total, the starting point nato is the atmosphere. So the carbon dioxide in the atmosphere is being used by plants to make food, diba? Through photosynthesis, and then they also give off CO2. And also the animals kung mag-respire ta, pinhawa ta, we give off CO2, soil, and then wala siya, magkakahitabo ana. So there is carbon dioxide, carbon in the atmosphere, and then it will go down and will decompose and then back to the atmosphere. So really simple, it is a cycle good para sa ato ang nitrogen and oxygen cycle din na. Okay? So what are the interesting things about this carbon cycle? Ato ang discussion karon. Actually, this is a data from the Mauna Loa, Hawaii. So from Mauna Loa, Hawaii, it's the yearly variation of carbon dioxide concentration at Mauna Loa, Hawaii. So as you can see, every year gakuan siya, gataas ang oxygen concentration. So it will go back down again, then rise, then go back again. So if you can see the Earth, or that part of the Earth breathes in and breathes out carbon dioxide. Ba? So this is inhale, exhale, inhale, exhale, inhale, exhale of oxygen, carbon dioxide. So inhale paubos kay maubos sa concentration, then exhale carbon dioxide. So what happened now is that this the trend, as you can see, is rising, ba? So gataas gid siya, dili gid siya gaubos gid ang concentration sa carbon dioxide. And what are the contributors to that? So primarily good, this is in the US, electricity production good, because they burn coal, and then coal produces energy, and then the byproduct of that is water vapor and carbon dioxide, and it will go to the atmosphere, dayon contributing to the rising trend of CO2 concentration. So, ikaduha dayon is cars and trucks. Cars and trucks. So, mga gasolina, diesel, it contributes. And then residential heating. So, sa tuwa, kaya wala tayo residential heating dito because we don't have winter. So, ito sa US, they have winter. So, ilag yung painitong inhang balay through heat pumps. And then industry. Industry. So, daghan processes sa industry. Sabi na sa tuwa, mga KMA, mga requires energy, and then we contribute to the overall rising trend of CO2. Diba? And then most din siya ang temperature. So makita ninyo as the CO2 levels rise, the temperature rise, the global temperature also rises. This is recorded from 1880 to 1996. So kita ninyo variation nga pataas gid ba, so ang kuan gid niya ang ihaging overall trend kay pasaka gid siya temperature. And what are the contributors to that? Primarily is the CO2, as we discussed earlier. Dayon, next is the chlorofluorocarbons, CFCs, and then the methane, and then the N2O or nitrous oxide. I think this is nitrous oxide. So yeah, next, let's talk about acid rain. So what really happens in acid rain? So acid rain day, guys, as I told you ganina dito sa volcanoes na part. So there is a atuang power plant. So nasunog sila diri og coal, and coal, mabalaan niyo na sa inyong check calculations na naa siya sulfur and then nitrogen na component. So if those parts are oxidized and burned, it produces SO2 or sulfur dioxide and NOx. NOx meaning kuan na siya, NOx kay pwede siya NO, pwede siya NO2, pwede siya NO3. It's actually a kuan murag combination or generalized form. So SOX, so ana X there represents numbers or integers. So when coal is burned, it musaka rin sa atmosphere, and then we have water in the atmosphere, right? So, kita na ganina nga kini siya SO2 will go dahil mo siyang sulfur, di ba, sulfur dioxide, and then further oxidized may mo siyang SO3. Dayon kung dugangan nimo siya tubig, may siyang H2SO4. Okay? May siyang sulfuric acid. And then also the NOx here, itong talang NO2 na siya, NO2. And then it will combine with water. So ang labas, nitric acid. Nitric acid. So when it precipitates, magulan na dayon, acid rain din ang labas. So what unsa may kuan niya, unsa may consequences niya? So the lakes turn acidic, and also malanay ang simina, malanay ang metal, ang tintal, yung balay, if it is not really protected, so magkuan niya mag-corrode. And next nga, what are we doing? So as chemical engineers, what are we doing? So di ba ganina, these are the industries. For example, kini ang exhaust gikan sa planta. This is one, by the way. Yes, this is a oil refinery. So gikan sa crude oil, so i-distill siya mahimong mga gasolina, diesel, kerosene, kanang mga gas. So what happens, diba? We don't want to let the sulfur and nitrogen go up to the atmosphere. So what do is we remove the sulfur and nitrogen as it is formed. So, diba ganina, and actually, ningin mo sa kuha, ano mang dili man nato ginakuha ang kuan kuya, ang mga sulfur and nitrogen sa coal. It's because it's expensive and it's not ideal, it's not optimal. So, di ba ganina as SO2 na NO2 forms, magsulod din na sila ani nga. By the way, this is called a gas scrubber. So this is a chemical engineering unit operation and ma-meet ninyo siya sa inyong third year, I think. So apoy CO2 and also there is water vapor. Kana sila nga mga gases, musulod na sila sa atong scrubber. So diri sa scrubber nato ipadto na to ang gas dito sa taas, and also we spray water. This is water, guys, water. We spray water diha sa kaning mga gases. So if we spray water there, so mag-react na din ning ato ang SO2 and NO2 sa ato ang water, so forming ngayon to konta lang H2 kuning diri sulfuric acid, nitric acid baka HNO3. And then the carbon dioxide is free to kuan. So ang exit na rin diri is CO2 na lang. Okay? So we have removed the harmful compounds that makes acid rain. So muna siya ang ginabuhat sa industry. And kining nangutan din mo sa kuya, kaning how about sa mga sa ato ang engines, di ba? Sa ato ang mga sakinan. So, muna siya ganina, this is stationary source. So, what about the mobile sources like the engine, the motorcycles, or automobiles, di ba? So, nasa tayo ginabuhat na guys. Chemical engineering hapon, which is your catalytic converter. So what is a catalytic converter? First, I have to tell you about the photochemical smog. Photochemical smog is a combination of smoke and fog. Smog is formed by the reactions of automobile exhaust in the presence of sunlight. For example, naatay ingani nga exhaust itong judayo, guys. I don't want to get near to that. So as the engine burns the fuel in your automobile, so it produces this pollutant, nitrogen oxide, and then the carbon monoxide and unburned hydrocarbons. Okay, hindi na siya complete na combustion. So it is not 100% efficient. So naging kayo mga bilin ng mga hydrocarbons. So what does it do is that when kung magawas siya sa atmosphere, it will react with the oxygen. So nato lang yung mga O2 dara. This NO will combine with the O2 here to form NO2, and also naputay mag-form ng mga ozone, which is really toxic kung naaka diri sa troposphere, but ozone is only beneficial if naa siya sa stratosphere, but it is toxic kung naaka diri sa troposphere. So what we do is that we put catalytic converters diri sa ato ang pambutso, atong exhaust. What does it do? Unsa na diri sa sulod is that it is embedded with elemental oxygen. For example, this floating molecule here is the carbon monoxide. So it reacts with the elemental oxygen here to form CO2. CO2. So muna na siya karon, dili na ang mugawas din sa tuwa is a odorless and colorless gas. Dili na siya ingani itom because kini carbon monoxide man ni. But if i-transform niyo siya to CO2, ayun na rin siyang colorless. Okay? And actually, you have to maintain this siguro once a year, inyo siya i-replenish kay hurot man yung mga embedded yung mga oxygen mga elemental oxygen. So you have to replenish this for the catalytic converter to maintain its efficiency. All right. So actually, this is the last slide. So it was the last slide. So if you have any questions, you can find me at muna niya akong name sa FB, guys. And si Ayo akong profile picture. Ayo mo ka kuan, ay mo ka katingala. Muna na siya. Okay. So actually, this concludes my first lecture to you. And bye for now. Thank you. Thank you.